Okay, so essential question for today is, how do you tell the difference between probability and odds? They are very similar terms and they're very often confused for one another. How do you tell the difference between probability and odds? Okay. So when we think about games of chance or something like that, is often where we think about this is something like flipping a coin, rolling a die, drawing a card from a deck. Those are called like an experiment. Okay? You could think of like shooting a basket as being an experiment. Drawing a marble out of a bag can be an experiment. Um, Putting slips of paper into a hat and then drawing out names, that could be an experiment. Okay? So then a particular outcome of that experiment would be called an event. So here I just wanted to talk about like some experiments and then what a possible event might be. So if our experiment was to flip 2 coins, what's something that could happen when we do that? What could be one of the events? Flip 2 coins, you get 1 heads, 1 tails. Okay. Okay. What if your experiment is rolling 2 die? Rolling 2 dice. What's something that could happen? Five and 4. Okay. What if the event is to draw a card from a deck? What's something that could happen? I'm sorry, the experiment is to draw a card from a deck. What's an event? 4 parts. Okay. So there's an event can be what happens, but then usually oftentimes we think of like the desired event, right? Maybe our desired event was to get 2 tails. Maybe the desired event was to roll doubles. Maybe the desired event was to get the ace of spades. Who knows, right? So there's events, and then there's the desired event. So what are we wanting to happen? What does happen? The total collection, that's fine. The total collection, total set of all the outcomes for an experiment. So the total set of all the outcomes for an experiment is called the sample space. So it's often important that you're able to identify what the sample space is, or at least how large the sample space is, as part of figuring out probability. So just think about that. Like, what are all the things that could happen? And then we use this notation P of E. So it's kind of like function notation, P of E, f of x. to describe the probability of an event. But what we would say like the probability of flipping a heads into tails. Okay? So what's the probability of flipping a heads into tails? Or what's the probability of rolling a 5 then a 4? All right, what's the probability of pulling out the 4 of hearts? Okay. So it's just a shorthand way of saying probability, right? Just saying P instead of probability, and then of what our desired event is. Okay. So that's just how we would say it in a shorter way, right? So you're going to see that here, like, what's the probability of rolling a sum of 7? Right? What's the probability of flipping 2 heads? So that's just the notation we're using to shorten down the writing. Okay. The formula or whatever, how you figure out probability, it's just a fraction, right? It's just a ratio. It's the number of ways the event can occur, divided by the total number of outcomes. So the number of ways the thing you want can happen divided by the total number of things that could happen. So again, it's not the math that's the issue, it's more the thinking about the situation, right? The math itself is just a fraction that you're writing, but it's making sure you understand the situation, how many things can happen, what am I looking for, and all that stuff. So it's a lot more thinking than doing with these problems. So a lot of times if we're going to try to figure out what probability of an event is, we need to make sure we understand like those two things. It's really just two questions, right? How many ways can I roll a sum of 7 on 2 dice? And then how many total outcomes are there for 2 dice when I roll them, right? How many ways can I flip 2 heads? How many things could happen when I flip 2 coins, right? How many ways can I draw a jack versus how many things could happen when I just draw a card? So making sure you answer those 2 questions and you just write them as a fraction. So it doesn't matter which order you answer them in. So if we just pick something and say, well, I'm going to think of all the ways that we could roll a 7 or sum of 7 with 2 dice. So if the first die I roll is a 1, then the second die would have to be a 6. Right? The first die I rolled was a 2, the second die would have to be a 5. The first die I rolled was a 3, second die would have to be a 4. First die was a 4, second die would be a 3, right? So on and so forth. So there's 6 ways to roll a sum of 7 when you roll 2 dice. How many total ways are there to roll 2 dice? Not 12. Where'd you get 12 though? So we have a 6 and we have a 6, but think about what we've been doing lately, Grant, right? 36. Why is it 36? Yeah. So there's 2 events, right? We have 6 choices the first event, 6 choices the second event. So we're using, what math was that or what was the idea that we used when we did that? What was that called? Took the number of events times how many choices there were in each event. That gave us our total number of options. What was that called? What was that math we were doing a couple days ago? You guys were figuring out how many outfits there were, how many meals there were. Helps us figure this out. It's 2 events, 6 choices each event. So that means there's 36 total choices. What was that called? it was the counting theory, the fundamental theory of counting, okay? Fundamental principle of that counting. So we're just using counting theory here to say there must be 36 choices, right? So don't add, but multiply, right? So there's 36 total outcomes. So our probability would, of course, be 6 out of 36, which would reduce down to 1 out of 6, which could also be written as a percent if you want. So what percent is that? To the nearest tenth of a percent. That's 1/6 is a percentage. To the nearest tenth of a percent. One more number. Yeah, 16.6%. Okay. So we have to be able to identify the number of ways this can happen, and then the total number of things that can happen. So that's not a lot of math, right? But it's just a lot of thinking. Okay. Now the only math we did here was one multiplication and then some divisions, right? Not a lot of math, but a lot of thinking. How can I make this happen? Well, the total number of things that could happen. Right? So making sure you're really understanding the situation that you're in. Right? So we're flipping two heads, right? So we're flipping two coins. What are the total things that could happen? What are all the things that could happen when we flip two coins? What's our sample space? Two heads, okay, what else? Two tails, what else? Heads and tails, anything else? Tails and heads. So there's our sample space. There's all four total outcomes. How many of them are what we want, right? How many is our desired outcome, right? Which is the two heads. So 1. This one's a little easier, obviously. So 1 out of 4. Of course, that does not reduce. So it could also be, of course, 25%. Okay. Again, probabilities can be written as fractions. Probabilities can be written as percents. Probabilities also could be written as decimals. Okay. So there's multiple ways to represent a probability. But usually it's a fraction or a percent. All right. What about the probability of drawing a jack? I mentioned, I think yesterday, or not yesterday, but maybe the day before that, if you're not familiar with cards, which I know is just something that's happening more and more. We're going to be talking about cards quite a bit in this unit. It's just something that's, like, as far as games of chance go, cards are pretty prevalent. So that's some questions you need to be asking of someone. Like, I don't know what the suits are in a deck of cards. Like, you need to figure it out. Like, you don't know what the cards are in a deck of cards. It's going to make some of this a lot tougher. So you may just need to talk to your parents about cards or something, or talk to somebody about cards so you can know what the names of them and stuff are. So if we want to draw a jack out of a deck of cards, how many jacks are there in a deck of cards? 4. So it's 4 jacks. How many total cards are there in a deck? Yeah, about 52. Okay, so there's 52 total cards out of, there's 4 that are jacks, so of course our probability is just 4 out of 52. Can we reduce that? 1/13th? And then what would that be as a percentage? Which is it? Is it rounding? Round up or round down? Okay, yeah, all right. Okay. So understanding the ways to make what you want to happen versus the total ways that things could happen. That's how we talk about probability. Next little bit deals with this idea of what's the probability of something not happening. Okay, so we're just going to compare those things. And what this is called the complement. Okay, so when we talk about this, the probability of something not happening, that's the complement of the probability. It's not like the, gee, Matt, you look nice today compliment, but it's more along the lines of like complementary angles. We're back in geometry, complementary and supplementary angles. The complementary angle was the one that added up to 90. So I had a 20-degree angle, then its complement was the 70 degrees that filled out the rest of that 90. So when we think about the probability, the complement of that probability is going to be what fills out the rest of it. So if I think about all the things that are jacks, right? There's 4 jacks in the deck. Well, that must mean that there's how many cards that are not jacks in the deck? 48. So there's 48 out of 52 cards that are not jacks. So I have a 48 out of 52 chance of drawing a card that's not a jack. And of course, 4 out of 52 is 1 over 13. So 48 out of 52 is going to reduce down to what? $12 out of 13, yeah. Okay. So 12 out of 13 chance of not drawing a jack. We saw the probability of flipping 2 heads was 1 out of 4. So how many things were there that weren't 2 heads, right? There was 1, 2, 3 things that weren't 2 heads. So the probability of not flipping 2 heads would be 3 out of 4. There's 3 things that are not 2 heads out of 4 total things. Okay. I changed the next one a little bit. Probability of rolling a 3. Right? There's one way to roll the 3 when you roll a die. There's 6 total things that could happen. So we say, what's the chance of not rolling a 3? Well, there's 5 things that are not 3 on a die out of the 6 total things. So when we look at those probabilities and their complements, what do you guys notice? When you look at the probabilities and their complements, what do you notice? What's going on here?
Is it that the denominator stays the same?
So denominators are the same. Right? That's one thing.
Numerators are on the complementary side, they're all 1 plus.
That may be true, but it's not. Yeah, it's just a coincidence. So, yeah, Matt noticed that all the numerators here were 1 less than the denominator, but that was just purely because that was because of the examples I picked. It's nothing to do with anything mathematical. What else? When you look at the probabilities and the complements, we notice. How many together they equal 1? So if we say the probability, I'll use a different letter. So the probability of some event plus the probability of the not event, when you add them together, they have to equal 1, right? Or 100%. Okay? So if it's in the fraction or decimal form, they would add together to be 1. If it was in the percent form, they would add together to be 100%. So, right? And so oftentimes when you go to look for a probability or you go to look for a complement of a probability, it can be kind of tricky to see all of the things you want to see. It might be easier to see one or the other. You can't see everything. We're looking at fairly small experiments, like drawing a jack. We have enough experience, with cards to know that, yeah, there's going to be 48 cards that aren't jacks. But maybe we don't know that. That could be tricky to figure out. But, flipping 2 coins, we can see up here, because we wrote down the sample space, that there's, 4 total and that 3 of them aren't heads, right? Or we know that, rolling a dice that 5 of the sides aren't 3. What if we don't have enough information there, or if we're not familiar enough with the situation to figure out that? So the way we can take advantage of that is like, what if we said that like, the probability of it raining today was like 0.127, okay? Well, now I say, well, what's the probability of it not raining, right? Well, if I don't know enough information to say that, like I'm not a meteorologist, well, how do I figure that out? And the probability of not rain, it's the difference from 1, right? So if they have to add up to 1, then I would just subtract what I know from 1, and that would give me the probability of the complement. So that would be 0.837. Okay. So there's like a 12.7% chance of rain, and then that means there's about an 83.7, not 3, 87.3, that's what I would say. 87.3 chance that it's not going to rain. Okay. So you can use this idea to your advantage that they do have to add up to 1. If it's not easy to see the sample space, if you don't have enough information, you can still figure that out just by subtracting it from 1 or from 100%, depending on what form you're looking at. Anything about probability you guys want to talk about? We're going to flip it over and start talking about odds. So I want to make sure you guys are clear on this before we move on. And these two terms are so oftenly confused, so we got to be really careful about that. It's like most of the time when people say odds, they probably actually mean probability. Just use the words interchangeably when they really should be. When we talk about odds, we can talk about odds that are in favor of something. We also talk about the odds against something. So it's kind of like the probability of something happening and the probability of something not happening. It's similar to that. When we talk about odds, what we mean is the number of ways that something can happen, number of ways an event can occur. And we're going to use a colon this time to represent the odds. Again, odds could be expressed as a fraction, but it's better if we don't, because then again it gets mixed up with probability. So we're going to use a colon instead. So something like 2:3, like that'll be our. We would say 2, 2, 3 is how you would say that. Versus if you wrote it as a probability, that would be 2 out of 3. So when we use a colon, we're saying 2, 2, 3, or whatever, 17 to 20 or whatever. So we use the word 2 when we use the colon. When we write it as a fraction, it's 2 out of 3. This would be more of a probability way of saying it. This would be the odds way of saying it. So we talk about odds, number of ways an event can occur versus the number of ways the event cannot occur. So number of ways the event or an event cannot occur. So it's all about that second number. In the probability, the second number is the total number of things, total number of outcomes. In the odds, the second number is just the ways for it not to happen. The first number is the same value. So again, they're so similar, right? Half of them are the same. We get confused really easily. Okay? Odds against is just basically the flip around. Right? So if the odds for something happening were 2 to 3, so 2 times it would happen, 3 times it wouldn't, odds against it happening would be 3 to 2. So I'm just going to take these two statements and turn them. Right? I would kind of call those reciprocals of each other. So odds against is the number of ways an event cannot occur. to the number of ways it can. Just really be careful. Again, it's that totaling idea. With the probability, the second number is a total. With the odds, the second number is just the ways it doesn't work. So if I was thinking about like what are the, pretty simple one is what's the odds of rolling a 4? Well, there's one way to roll a 4. There's 5 ways to not roll a 4. So one way to roll a 4, 5 ways that are not 4. So the odds of rolling a 4 are 1 to 5. Whereas, versus the probability of a 4 would be 1 out of 6. Okay? So these are very closely related, and there's a relationship between the 5 and the 6. Okay? The odds of drawing a queen. So how many ways can you draw a queen out of a deck? Well, there's 4 queens in the deck, and there's 48 not queens in the deck, which would be the same thing as 1 queen versus 12 not queens, right? Reducing it down, reducing that ratio down. So that would be the odds of drawing a queen. Again, versus like the probability of a queen would be 4 out of 52 or 1 out of 13. Again, a lot of similarity here between these things. Okay? So 4 out of 52, 4 to 48. 1 out of 13, 1 to 12. Okay? When we say that phrase out of, we're implying that that 1 is part of the 13. We're saying like the 1 to 12 that they're separate. We're comparing them, but that 1 is not part of the 12. So that's how we move between the two statements, right? How do we move between probability and odds? Right? If I know the probability of something, how do I calculate the odds? If I know the odds, how do I calculate the probability? Okay. So really what it comes down to is just, are you really sure about the definition? Right? What does probability stand for? So if I say the probability of rain is 1 to 3, or 1 out of 3, what does that actually mean? Right? It means 1 rain out of 3 total, right? So if we're thinking like, if we thought of 3 days, right? Then one of the days it rained out of the 3 total days, right? Well, in order for us to think about odds needs to have that same thing. Like, how many times did it rain? It rained once, but now we're comparing it to the number of times it didn't rain. So, well, how do I figure that out? Take the total minus what happened, right? Of course, that's 2. So the odds of rain would be 1 to 2. So it's not a lot of math, right? All I do is subtract, but it's figuring out that that's what I need to do is the hard part. Right? How do I go from 1 to 1? Oh, I just need to subtract those. It's more thinking than doing. Probability of rain is 1 out of 3, then the odds of rain are 1 to 2. That's going from probability to odds. Next one says the odds of North Carolina winning the championship in 2017 were 6 to 5. I'm going to rewrite that. I shouldn't have typed it that way. 6 to 5. What was the probability? What does 6 to 5 mean? Right, when you go and think about odds, what does 6 to 5 mean? That's 6 wins, and then 5 not wins, so 5 losses. So if they would win 6 times, they would lose 5 times. What's probability mean? Right, probability is a fraction, where the numerator is how many times did it happen, how many times the thing we want happened, and they wanted to win. That was 6. But the denominator is total, right? Well, they won 6 times, they lost 5 times, so the total we would need to add. So the probability is 6 out of 11. And not a lot of math, but just remembering, like, figuring out which do I do? Do I add here or do I subtract here? Right? That's the hard part, just making sense of it. I'll do one more of those and I'll come back and check on you guys, see if there's something you want me to clear up. So the probability of flipping the heads 3 times in a row is 1 out of 8. We saw earlier that flipping it 2 times in a row is 1 out of 4. Doing it 3 times in a row is 1 out of 8. So what's the odds against? Right? Odds against doing it 3 times in a row. Right? So if the probability is 1 out of 8, what does that mean? All right, that's 1 heads out of 8 total. For me, I like to go from probability to odds and then to odds against. I don't have to do that. There's nothing making me do that. That's just like what I like to do. Okay, so I'm going to turn this into odds. So the odds for, oh, and I forgot to mention, if it just says odds of, like it says the odds of drawing a queen, the odds of rolling a 4, that's automatically odds for. Okay, so if it says odds of, that's odds for something. You have to very specifically say odds against if you mean odds against. So if it doesn't have to say odds for rain, odds for drawing a queen, odds for rolling a 4. That's just assumed. If it needs to be odds against, it has to say odds against. So the odds for rolling, or sorry, getting 3 heads in a row, well, one time it would happen. But 7 times it wouldn't. The odds for it would be 1 to 7. That means the odds against would be 7 to 1. There's nothing stopping me from going from here to here in one step, right? I can do that. I just don't like to do it. So usually, like I said earlier, we don't, when people say odds, they don't usually mean odds. They usually mean probability. They just, we use those words interchangeably when you shouldn't. It's kind of like with the combination lock thing. We probably shouldn't say combination lock because it's more of a permutation. But usually probably the only place you would ever see odds is like dealing with sports, like sports betting, things like that. I don't know really where else you generally see it in your day-to-day life. So when you do place like a bet on sports or something like that, like if you went to Vegas and said, I want to place a bet on flipping 3 heads in a row, well, they're going to say, well, the odds against that are 7 to 1. And so you'd put down your dollar. And if you flip your 3 heads in a row, or however the game's played, if somebody else flips the 3 heads in a row, they would give you $7. Right? One of those dollars they gave you back would be the one that you bet. So they would be giving you 6 back on top of the one that you bet. So, okay? So you put down 1, they would give you 7 back. So if you put down $100, they would give you $700 back. Again, 100 of that would be yours, and 600 on top of that. So that's how that works. Like when you go and make bets on things, and the odds they would give you the odds against it, and then you bet against that. So like Kentucky Derby was last weekend or 2 weekends ago. I have no idea what the odds of the horse that won were. I have no idea what the odds were. But let's just say that the odds against that horse winning were 3 to 2. So 3 times the odds against them winning were 3 to 2. So that means 3 times he's going to lose, 2 times he'll win. Okay. So if I put down $200, they'll give me $300 back. So that means they're only giving me $100 on top of that, my original $200. Okay. If I put down $400, that's 2 200s. they would give me 3 200s back. So they give me 600 back. So when you're placing bets, that's how that works. Not that I'm encouraging to place bets. Not that I do place bets. Just that's how it works. So. Something else we see with betting is like they have things called lines, and I've never explored that. Like they talk about a line of something on a line on something. Like they say like plus 150 or minus 300. I don't know what that means. So, but that's another betting term. Anything? Probability to odds to probability. Seeming super funky. I'm not exactly sure if we'll be able to finish all this in the time we have, but we'll see. Yeah, we won't be able to. We'll have to finish it up on Monday. Okay, so what about the probability of multiple events happening? How do we deal with that? So what's the probability of rolling a 3 or rolling an even number? How do we figure that out? What is the probability of rolling a 3 on a die? 1 out of 6, okay. What's the probability of rolling an even number on a die? 3 out of 6, okay. So what's the probability of rolling 3 or an even number? Why is it 4 out of 6? Sound together? Can we just do that? Can we just add our probabilities again? Does it work? What's the sample space for rolling our die? The size of it is 6. What is the sample space? Size of the sample space is 6. What is the sample space? What is the set of all the outcomes for rolling a die? 1, 2, 3, 4, 5, 6. Okay? So I'm saying you win this game if you roll a 3 or if you roll an even. So there are 4 ways to win out of 6. So does it work? Can we just add the probabilities? Yeah, sweet. Easy peasy. So what's the probability of rolling a 3 or rolling an odd? Three out of 6? Why is it 3 out of 6, Maddie? Why is it different?
Because 3 is an odd, so it doesn't count as 2, it just counts as 1.
Can you say that again?
3 is an odd, so you're not adding any more. It just counts as 1.
Just counts once. Okay. So Maddie's saying that because 3 is an odd, we can't just add it again. Probability of rolling a 3 is 1 out of 6. Probability of rolling an odd is 3 out of 6. But 3 was one of those odd numbers. We can't add it again because we would be double counting it that way, right? Like we give it a vote because it's 3, then we give it another vote because it's odd. We're letting it count twice, right? Letting it vote twice, right? That's not okay because if we look back at our sample space, 1, 2, 3, 4, 5, 6. When do I get to win? Well, I get to win if it's a 3. I also get to win if it's odd. I only get to win 3 times out of 6. I don't get to win 4 times out of 6. Right? So we can't just add them. So how do we take care of that double counting? Right? So what you end up doing is subtracting the number that shows up more than once. So 1 out of 6 plus 3 out of 6 minus 1 out of 6 again gives us that 3 out of 6 that's the actual answer. So what this deals with is an idea called mutual exclusivity, or are the events mutually exclusive? Okay. The events in the first situation there, rolling a 3 and rolling an even, are mutually exclusive. which means they can't happen at the same time. I can't, if I'm rolling one dice, I can't roll a 3 and an even at the same time. So they are mutually exclusive. So if the events are mutually exclusive, we can just add the probabilities. If the events are not mutually exclusive, we can add the probabilities, but then we have to then subtract what was double counted. Okay? And this becomes one of those things where you really have to pay attention to what's going on in the problem. Again, it's more of a thinking issue than a math issue. So mutually exclusive events cannot happen at the same time. It's okay to add them. But if they aren't mutually exclusive, if they do share outcomes, so if the events do share outcomes, we have to subtract back out those ones that were double counted. We only subtract them out once. You don't subtract them out completely. We don't just say, well, 3, you try to get in there twice, you're out of there, right? 3 still counts, it just only gets to count once. So we have to take out the doubling. So we're taking out, we put 3 in twice, but then we take it out once. Okay? I'll just call them doublers for fun. They don't have a specific name, but so the idea there was we put 3 in, we put 1, 3, and 5 in, and we had to say, oh, 3, you tried to sneak in, you're gonna come back. One of those 3s gets kicked out, and we're just there. Okay, so we'll try to wrap that up. Those last 3 on Monday. Again, I would like you guys to go ahead and start these, see what's sticking with you. These last 3 problems you probably need to wait on, so you get a little bit more experience with those. But try those first 6 or so. We'll finish this up Monday. You guys will have time to work on Monday.